We are constantly swimming in a sea of data. Numbers, charts, statistics, they're all supposed to help us make sense of the world. But what happens when they're actually designed to fool us? Well, today, we're going to pull back that curtain. We're going to look at how data can be used to mislead, and more importantly, how you can spot the truth.
Let's just start with a number, 800%. Let it sink in. Imagine you're scrolling online and you see a headline that says you might have a gene that gives you an 800% increased risk of something bad. Yeah, something like a life-threatening blood clot. I mean, that number, 800%, it's terrifying, right? It's specifically designed to grab you by the collar, get your heart racing, and maybe even cause a little bit of panic. So, the big question is, should you be worried? And the answer? Well, it's a bit more complicated than a simple yes or no. And that complication is exactly what we're going to untangle today. You see, the whole secret lies in understanding the difference between two kinds of risk. That huge, scary 800% number, that's what's called a relative risk. And while it's technically not a lie, it sure doesn't tell you the whole story. So what's the difference? Well, relative risk compares one group's risk to another, which can make any change sound absolutely massive. And our brains, they love these big, dramatic numbers. Absolute risk, on the other hand, gives you the real-world odds, the actual context. Let me show you with a super simple example. Okay, picture a factory with exactly 100 workers. If 20 of them are dealing with back pain, the absolute risk of having back pain in that factory is just 20 out of 100, or, 20%. It's the straightforward, no-nonsense number of people who are actually affected. Simple enough, right? Now, let's say the factory introduces this great new exercise program. A year goes by, and now only 8 workers have back pain. That's fantastic. But just how fantastic depends entirely on how you decide to frame the numbers. So if we look at the absolute risk reduction, we went from 20% of workers with pain down to 8%. That's a drop of 12 percentage points. A solid, meaningful, real-world improvement. But you could also spin this another way. We could calculate the relative risk reduction. The number of people with back pain dropped from 20 down to 8. That's a 60% drop compared to the original number. Now that sounds way more impressive, doesn't it? It's the exact same result, but come on, which headline are you going to click? Program reduces back pain by 60% or program reduces back pain by 12%. It's a no-brainer. This is how easily numbers can be tweaked to be more sensational. And the same idea applies to visuals, too. Yup, it's not just about the numbers themselves. The way we see them, the charts and graphs, can be just as deceptive, if not more so. Take a look at this customer satisfaction chart. At first glance, everything looks amazing. Quality, service, value, all of them are scoring above a 4 out of 5. You'd look at this and think, wow, this company is absolutely crushing it. But what if I told you that the most important information is what you can't see? This is a super common technique called cherry picking, where someone only shows you the data that makes them look good. And there it is. When we add in the rest of the survey data, a totally different picture emerges. Oof, delivery time and the website are scoring pretty poorly. See, just by leaving out a couple of columns, the story changed from "we're doing pretty well" to "we are the best in the world." Here is another classic trick. Look at this chart. Man, it looks like product B is just destroying product A, right? The bar for B is like twice as tall. But take a closer look. Pay very close attention to that vertical line, the y-axis. Do you see it? It doesn't start at 0. It starts at 95. This is called manipulating the axis, and it's a sneaky way to make small differences look like enormous gaps. So let's see what happens when we fix that baseline and show the real picture. And there you go, the data has not changed one bit. It's still 100 units versus 120. But by starting the axis at 0 where it belongs, we get a much more honest view. The difference is still there, for sure, but it's not the giant, world-ending gap it looked like before. It's no longer a visual lie. And all of this leads to maybe the single biggest trap in all of data analysis: confusing correlation with causation. Our brains are wired to see patterns, so it's really easy to assume that when two things happen at the same time, one must be causing the other. You've probably heard the classic example, right? Ice cream sales and shark attacks both spike in the summer. Does eating ice cream make you more attractive to sharks? No. A third thing, hot weather, causes both. More people swim and more people eat ice cream.
Okay, so you're probably thinking, this is a minefield. How do I protect myself? It's a fair question. How do we become smarter, more critical consumers of all this information? Well, the good news is there's a pretty simple toolkit you can use. It's called the CRAP test. Yeah, I know. It's a memorable name. You're not going to forget it. It's a 5-step checklist to mentally run through before you just accept something as true. C is for currency. Is this info new or ancient? R is for relevance. Does this even have to do with the topic at hand? A is for authority. Who is saying this, and do they know what they're talking about? The second A is accuracy. Can you find this information somewhere else? And P, this is the big one, purpose. Why does this exist? Is it here to inform you, or is it trying to sell you something or persuade you? Okay, let's bring this all back home. Remember that terrifying 800% statistic we started with? Let's go back to it now and apply everything we've just learned. This right here, this is the missing context. The absolute risk of getting a blood clot for someone without this gene is just 1 in 1,000. An 800% increase of that tiny, tiny number brings your risk up to 8 in 1,000. Yes, it's higher, but look at it this way. Your chance of not getting a blood clot is still 99.2%. That scary headline told a piece of the truth, but not the whole truth. It gave us the number that would cause fear, not the one that would allow for understanding. And this really gets to the heart of it, summed up perfectly by the author Alberto Cairo. A chart shows only what it shows and nothing else. It sounds so simple, but it's such a powerful reminder to always be critical, to always wonder, what isn't this chart showing me? So I'll leave you with this thought. The goal here isn't to distrust everything, not at all. It's to be more curious, to be a more critical thinker. So the next time you see a number that makes your jaw drop or a chart that looks just a little too perfect, what's the first question that's going to pop into your head?